Thank you for watching my video. My name is Mr. Charles Wenike. In this video tutorial, we are going to discuss much more about optocoupler. It's not only just on these parameters of optocoupler and optocoupler specification. I have other details that I'm going to discuss under this particular topic. Then let's start. Parameters of optocoupler specifications. Parameters and specifications that need to be taken into account when using optocouplers or opto-isolators are current transfer ratio, isolation voltage, bandwidth. In this case, we are going to discuss all these things in details. Let's proceed. Current transfer ratio. Current transfer ratio describes the relationship between the input current and between the output current and the input current that causes it. This is a minimum value expressed as a percentage of the input. The most convenient way of specifying optocoupling efficiency is to put the output to input current transfer ratio of device. That is the ratio of output connector current of the phototransistor or any of the light sensors to the forward current of the LED. In this case, what I am explaining here is, from the starting here is, in terms of this particular current transfer ratio, this is the one that describes the relationship between the output current and the input current. You know, current will start from the source, being from the input before getting to output. Now, in this current transfer ratio, it is expressed in percentage. Just I explained in previous video. It expressed in percentage the input current. So in that case, we also did the small calculation. It's not too much. Now, in this case now, this CL, this IL, this current C is stand as a connector current. Why? In terms of this forward current, which is this F is forward, while this one, this I stand for current in terms of the LED. Remember, the ratio of the output connector, this one stands for output connector, being the connector current of the phototransistor. It could be, it's not only phototransistor, it's just, I use only phototransistor as an example. It could be photodarlington. It can also, or it could also be photo SCRO or a trace, all depending on anyone. But this is just for an example aspect of it. So what I'm trying to explain here, the ratio of the output current of the phototransistor to the forward current of the LED, because the LED will forward the current give to the light sensors or for the photo detector, all depending. Now, in this case, thus, current transfer ratio, this one is an abbreviation, just as I explained before, connector current and forward current. Connector goes up. In terms of mathematics, we call it numerator and denominator. Here is denominator, why this one is numerator. The connector current is the numerator, while the forward current is the denominator. That is, in terms of practice, the current transfer ratio may be expressed as a simple figure such as 0.5, just as an example. I'm taking it as an example by multiplying this figure by 100, because whatever thing that has to do with percentage, you must multiply it by 100%, which once you multiply it, 0.5 will now give you the figure of 50%. You can use 0.1, you can use 0.2, all depending. Why I use it is just for an example purpose. Typically, CTR space are is around from 10 to 50%. It's in between from 10 to 50%. These devices operate similarly to step-down isolation transformer. They all work similarly to step-down isolation transformer, which I use in the order of the difference between AC and DC optocoupler, which I told you that is a SMPS transformer, which I said that one is step-down transformer. Optocoupler is as well work similar aspect of it. Optocoupler are designed to step up current into the output circuit. You can see that now. Optocoupler is designed to step up current into the output circuit. Often those with photodarlington outputs can reach 600%, 600% or more, all depending. This photodarlington is just an example. It's not that it's only photodarlington. It could be any light sensors, all depending on usage, the one that you are about to use. So in that case, current transfer ratio reaches its maximum value when the input light sensors is brightest. It's obviously that in this particular explanation, what I am trying to explain here is the current transfer ratios, it reaches maximum value when the input light sensor is brightest. That is the maximum value aspect of it. Now we go to isolation voltage. Isolation voltage, I have already mentioned this in my previous video, is sometimes referred to as input to output isolation voltage and is one of the more important optocoupler specification. Isolation voltage is one of the most important optocoupler specification in this aspect because the isolation voltage, that is where the optocoupler comes into function, which I use that power board to explain the isolation voltage, which is talking about the difference between the voltage levels, the voltage from the primary source to the secondary source. They might not be the same. The one that is in the primary source may be greater or bigger than the one that is secondary source, or the one that is in the secondary source may be bigger than the one that is in the primary source, all depending on SMPS transformer which they use, or all depend on what you are about to construct. That is what I mean by that. So in that case, isolation voltage represents the maximum voltage that can be applied to both the input and output circuits while still maintaining electrical isolation. That is just what I mean by that. I've already explained it before. That is what I mean by that, because this isolation voltage, it has a bold line that separates or that isolates the primary board from the secondary board of the cold aspect from the hot aspect. All is isolation voltage. That is where you see optocoupler comes on board. That is where you see SMPS transformer. You will also see that it could be step down. It can also be a set up, as in step down and then step up and then a transformer aspect, all depending on the manufacturer or what you in per se are about to construct. That is what it means here. And it will be boldly it will be boldly demarcated by a bold line where you will see it. The line will be demarcated to show you that this board from this section to this section, it has been demarcated by isolation voltage. You can also call it by isolation circuit. Bandwidth. This is a typical maximum signal frequency that can be usefully passed through the optocoupler when the device is operate in its normal mode. Typically values, it varies from 20 kilohertz from the 20 kilohertz to 500 kilohertz, all dependent. In this aspect of it now, it only depends on the light sensors, depend on the device construction. It could be a DC phototransistor. It can also be an AC phototransistor, all depending on the devices that you are about to use. Now, this is basic operation of opto-isolator. You can call it optocoupler. You can also call it opto-isolator. They are all the same thing. Now, in this case, let's talk about this now. The optocoupler is a component that contains the two elements. What are the elements? Light emitter, which is the diode. Light emitter, which is the diode. The emitter is on the input side and takes the incoming signal and converts it into a light signal. Typically, the light emitter is a light emitting diode. That is what I'm telling you. What I'm trying to explain here is in that optocoupler, it contains two elements. One is what? Light emitter, being what? A diode. The other one, because this particular light emitter is the one that takes in the current from the source, while the other light sensors, being light sensor, is the one that will be at the output. So in that case now, after this particular light, after this now, once it has taken, it now converts it into a light signal, because the current that is coming into it is either current or voltage, is an electrical aspect. Now from there, the diode, what it does is to convert it into a light signal. Typically, the light signal is what? Light emitting diode. That is what it does, being the diode. It converts it into a light signal. Now, this is a light detector. You can call it light detector. You can as well also call it light sensors. Now, in that case, the light sensor detects within the optocoupler or opto-isolator, detects the light from the emitter and convert it back into an electrical signal. The light detector can be any of the light sensors, which I have mentioned before. I said it could be a phototransistor, it could be a photodarlington, it could be a phototrace, it could be a photo SCR, all depending on your choice. So what it does now, after it has reached, after it has collected it, because it will detect that there is a light emitter. Now what it does is to convert it back to electrical signal the way it was, and then it will now transfer it, give it to the output. That is what it does. Remember that optocoupler, it contains two elements. One is light detector, two, light detector or light sensor, two is light emitting diode, being diode. The light detector, it could be a photodarlington, phototransistor, photo trace, or photo SCR, all depending on you that what you are about to use it for. Now, in case, let me explain much more, a little bit about optocoupler, what or how it works or how it functions. An optocoupler couples high voltages from one side of the circuit to the other without any direct electrical contact. If you remember the other previous visual, you can see that I used a power board to explain it, which there was a line demarcated it. It demarcates from the power, it demarcates from the primary section to secondary section. So what it does is what? It just it couples high voltage from one side to the other circuit. That is what it does. That is to transfer voltage from one section to another section. That is what optocoupler does. It's just, for instance, let me use bridge as an example. If without bridge, can we be able to use our leg to cross over the other sea, the other aspect of the side? That is why we have a scientist. They all came up with an idea which they now came up with an idea to construct a bridge. Now, it means that that bridge it works as an optocoupler. That is just the simple aspect of it, the simple explanation. The bridge works as an optocoupler, which it joins the higher voltage from the lower voltage, or it also transfer high voltage to the other circuit. It transfer a voltage from other circuit to other circuit, which means it joined two circuits together when they are isolated. Optocoupler join two circuits together, which means bridge as well. It join two separated boundary together, that it will give each and every one of us access to cross it without experiencing any other than danger. That is just the simple aspect of the function of optocoupler. I use bridge as an example. The device converts the electrical energy into a beam of light using a light emitting diode. That is what I have just explained before. You know, in diode it has plus and minus. The plus aspect of it is the one that takes in the current, while the minus aspect of it is one that is connected to ground. Remember, in optocoupler, the diode itself, the plus is the one that takes in the current, while the minus aspect is one that is connected to ground. It means that if there is noise or an excessive voltage, that noise, that particular one that is connected to ground, it will do what? It will stabilize or neutralize it. And from there, the diode will now convert the electrical energy into a beam of light using light emitting diode, and then directing the light towards a light sensor, which could be phototransistor, photodarlington, phototrace, or photo SCR. After that, which can convert it back to what? Electrical energy or electrical signal. Once all these things have been done, then the photo sensor will convert it to electrical signal back to the normal voltage, back to electrical signal. Now, once the light from the LED strikes the photo transistor, it starts conducting electricity depending on the state and duration of the light. You remember that I said optocoupler, the maximum that it will, is it conduct or anything, which I explained from the early video, which I said is the brightest when it has reached the maximum aspect of it. That is when you will see the brightest aspect of optocoupler. That is what they are saying. That is what I mean here. Once the light strike the LED, once the light from the LED strike the phototransistor, being the photosensors, then being the photodetector, it starts conducting electricity depending on the state and duration of the light. This isolates the two circuits, prevents voltage sparks. That is another work of it. It prevents voltage sparks from the two sides of it, from the primary source to the secondary source. The optocoupler, it prevents voltage sparks and decrease noises, as well as interference associated with communication connection. All these are the work of optocoupler. That is the function of optocoupler. Now, choosing the right optocoupler, before you choose or when you're about to build or do anything or whatever thing you have decided to do, you must consider the following. You consider the operating temperature, output voltage, isolation voltage, packaging types, and current transfer ratio of optocoupler. These are the most important thing that you should consider if you are to choose the right optocoupler. Just look at how it has numbered. This CTR, which I have already mentioned it before. Now look at it here. This is 0.36, 20%, 50%, 100%, and so on and so forth. Numbers of channels, you also consider the channel, 1 channel, 2, 3, 4, and so on and so forth. It has dual, it has so many of them. It has various channels. Those are the things that you should consider depending on what you are planning to build. And maximum operating temperature from 70 degrees to 150 degrees Celsius, to name a few. That is what I'm trying to explain here. This, if you are to choose optocoupler, put all these things in consideration, all depending on what you are planning to build. Now, factors that affect opto-isolator operation, optocoupler operation. Look at what are the factors that affect it. Now, in this case, here is the breakdown potential interior to the opto-isolator, depending on the factors such as the temperature. It means when the temperature is more than what is expected, the optocoupler must break down. Here is the humidity, which it could be in a cold weather, because each of them, they have a maximum temperature and the maximum freezing point that they can accept. Once it's beyond that, you see that particular distance, it will no longer work the way it's supposed to work. So these are the effects that affects the operation of opto-isolator or optocoupler, as well as the barometric pressure. The barometric pressure is as well as atometric. Is it in terms of air pollution? It involves air. This one here, it involves air pollution, and so on and so forth. Now, the types and concentration of the contaminant in the air, that just as I said, it involves air pollution. Now, the disadvantage of isolator, the opto-isolator or optocoupler. What are the disadvantages? It have limitations and cannot be used in some electrical system, that is for sure. It has a limitation and it cannot be used in some electrical system. affected by factors such as humidity, air pollution, and which can be cause arcing and interference with the isolation. All these are the disadvantages. Though the disadvantage is not too bad, but all I know is optocoupler is as well as useful. So these are the little disadvantage of opto-isolator or optocoupler. Now let's take a look of the advantages of opto-isolator or optocoupler, which includes providing electrical and physical isolation of two sections of a circuit, and hence the safety, and hence what? The safety. That is the most important thing. It provides the safety of a circuit. That is the most important thing. Whereby it also helps to reduce influence, as a noise influence. That is come from electromagnetic interference, that is EMI, such as from electrical interference. That it helps to reduce the noise influence from electrical interference. It's relatively small and inexpensive. It's very cheap, all depending on you. It's very, very cheap. And in this very small, you can also put it in your pocket. It's not too big that you can complain it's too heavy. You can also put it in your pocket. That is the most advantage of opto-isolator or opto-coupler. Ability to limit voltage across multiple circuits. Those are the most important thing of what? The opto-coupler. It has the ability to limit voltage across multiple circuits, as well as it provides isolation. It provides isolation. Now, application. Application of opto-isolator or opto-coupler. It are used in variety of optical application, including the power supplies, to provide isolation in the recording industries, to reduce interference, and in computer systems to transfer data. Now, in this aspect of power supply, it's not just only in power supply. Power supplies is just, for instance, a television board, SMPS board. It's so many of them. You can also see optocoupler in what we call even PoE, power over internet. You can also see it in laptop. All those things, power, opto-isolator or optocoupler, they are all there. That is in terms of power supply. Now, in terms of data being computer and so many of them, in terms of record industry, you can also they also use it there. Those are the applications, which include, which I have already explained, power supply or switch power supply being SMPS, medical equipment, regulating output voltage, microprocessor input and output. You can also see that it's used here. Signal isolation, electrical power, and noise isolation. Thank you for watching my video once again. Please, if you find my video useful, subscribe to my channel, comment, and like. Anticipate more video from me. See you in the next class.